Hello everyone. The last video for this week is a tinge off topic, but I felt it was important enough to start introducing you to exception handling, especially as we get into building classes and object-oriented programming. You may find this week that this will help you in diagnosing syntax problems with your arrays, and overall it's good to know when parts of your code are failing and have a fallback mechanism to either restart your application or convey there was an error to the user. Now there are two types of exceptions. Or two types of errors. One are compiler errors that you get when there's a problem building your application before you run it. Those are not really meant for exception handling. You use the error list, as we can see, that we've used many times before to see what errors are occurring during compile time. But during runtime, it's a little bit different. We want to know when there's an input problem with our application, and that may result in finding a logic problem in our code. Here's an example. Let's go back to week 1, week 2. I want to accept an integer input from a user. So I'm going to define an integer, int input equals 0, input equals, let's ask the user, console.writeLine, what's your favorite number? And here we want to say input equals int.parse console.readline. And then we want to convey back to the user console.writeLine. Great. Your favorite number is input. So what have we done here? We've declared a variable input. We've asked the user, what's your favorite number? We read that input from the user, and we relay that input data back to the console. So if we run this application, what's your favorite number? 42. Great, your favorite number is 42. And we end the application. But what if I'm an interesting user and I don't follow instructions properly? Maybe my favorite number is pi. But instead of entering a number, I go ahead and enter pi, P-I, as a string, and I hit enter. The world blows up and our application stops working, and we get a notification, unhandled exception. Now, if this was running on a user's machine, let's say you deployed your application would just crash. You wouldn't open up Visual Studio and it would tell you what is wrong. It wouldn't do anything. It would just fail. So this is a very basic example, but there is a way for you to recover when there is a problem during runtime. And these are using what are called try-catch statements. So let's stop this application. And we know that from the error that just occurred during runtime, where the problem in our code might be. So we know the problem in our code could be on line 17, where we get input from the user and then parse it as an integer. Well, we need to make sure that the value passed in is an integer. Without doing anything else, we could simply handle the exception using something called try-catch. So in order to build a try-catch block, it's two parts. First is the try block. We're going to try to do something. And you open it up with brackets, just like you do with switch statements, if statements, for loops. And the thing you want to try, you put in this block. So we want to try collecting data from the user and parsing it as an integer. The next step is a catch statement. And what we want to do in a catch statement is also catch the exception. So here, exception is a general type for an exception that is passed back to us. And EX will be the variable name or what we'll use. So what we've done here is we've said, all right, try grabbing input from the user and parsing it as an integer. If there's a problem, do whatever is in this catch block. So in this catch block, what do we want to do? We want to say to the user console.writeLine, looks like there was a problem with your input. Now, sometimes this takes a little bit of work. We're going to see there's going to be a problem. So let's run this application and figure out, is our try catch block really built the right way? Let's run the application. All right, what's your favorite number? We'll input 42. Great, your favorite number is 42. Let's run the application again. What's your favorite number? Pi. Well, this really isn't right. We caught the error, and it says, looks like there's a problem with your input. But then we still say, great, your favorite number is 0. Well, that's because we initialized input to 0 at the very beginning of the application. And we really don't want to show that when the user didn't enter the correct number. So looking back at our code, it makes logical sense to take this console.writeLine and put it in the try block. Because again, if this falls, then fails, we don't want to proceed with this. We want to jump right to catching the error and exiting the application. So let's try this again. What's your favorite number? 42. Great. What's your favorite number? Pi. And excellent. We tell the user there was a problem with their input. There is another part to try catch, and that's called finally. And in finally, it allows you to, no matter which branch you go to, let's say try works, or maybe you got halfway through try and you jumped to catch because there was a problem. Finally lets you, in both cases, do something. So both branches, the error state and the non-error state, come together and let you make a final statement. So in this case, we'll do console.writeLine, have a good day. Now, whether or not the user input is correct, we will hit this finally statement. So let's run this again. What's your favorite number? 42. Great, your favorite number is 42, and have a good day. So again, we read out what's your favorite number. We collected the input where I put 42. Great, your favorite number is input. And then we jumped to the finally code block, and it said have a good day. Now if we run this again, and I type in pi, looks like there was a problem with your input, but you know what? Have a good day. So in this case, we read the line, but the exception happened on line 19 here with that failed input. We input a string and tried to parse as an integer. So we went to the catch statement, After executing everything in catch, we execute everything in finally. Now, one last note here. You can also convey what the error was to the user. So here, console.writeLine, we can say the exact error was, and using the EX variable we defined in the catch statement, we can convert that to a string, ex.toString, and display that to the user. So now, when we type in, what's your favorite number, pi, the exact error was system.formatException, input string was not in a correct format. Well, again, we tried to parse it as an int. You see here, system.int32.parse. Now, what you're going to see here is the stack trace. And a stack trace is, well, what were the methods being called, the nested methods being called in order that triggered the error. This happened to be, okay, we called int32.parse, int32.parse called system.number.parseInt32, which then called method system.number.stringToNumber, which then raised a system.formatException because in it we passed a string that did not contain a number. So if you're ever wondering what a stack trace was, and as you get into debugging in your other courses, this is how you can dig deep into your code to figure out what exactly caused an error and where the error occurred. But in the short term, knowing what the exception was, in this case system.formatException, by revealing it through a catch statement and writing it to the string, really helps you get an idea of what the problem might have been. Now, this is just a very cursory look at try-catch statements. For instance, you can have multiple catch statements. You can have a catch-all, to use the term loosely, that catches every exception, but maybe we want to do something special when it's a string.formatException. We can do that. You can have a try statement with as many catch statements as you need for each different type of exception. I'm not going to go into that much detail, and I encourage you to explore on your own, but for the purposes of this course, try-catch can really help you not only figure out where some problems might be in accepting user input or handling arrays, but it can also give you a failover mechanism to keep your application running when there are problems during runtime.